Good morning, all. In first lecture of Fourier transform, we have seen that all the Fourier transform of fx formula, then inverse Fourier transform formula, Fourier cosine transform, its inverse Fourier cosine transform, then Fourier sine transform and inverse Fourier sine transform formulae. So these formulae we have seen in previous lecture. Then one example. Uh, Find the Fourier transform of fx given function fx and hence find the part or that term. So the next example is find the Fourier transform of fx is equal to 1 minus x square when mod x is less than or equal to 1 and otherwise fx equal to 0 when mod x greater than 1. So this mod definition we have seen in first example, that is if mod x less than 1 then x is in between minus 1 to 1, and if mod x greater than 1 then x is in between 1 to infinity. So this is your definition of mod function. So here again same condition is come here in this example. So mod x less than or equal to 1 means x is in between minus 1 to 1. The inequality is less than or equal to, and mod x greater than 1 means x is in between 1 to infinity, and hence deduce that this is your hence part required term, integration from 0 to infinity x cos x minus sin x upon x cube dx into cos x by 2. So and generally while in exam the question asks for this chapter, that is Fourier transform. Only Fourier transform is not asked. With that question, hence part is asked generally. So the question type in Fourier transform is Fourier transform plus hence part. So here again we have asked to find the Fourier transform of given function fx and hence part, to find this hence part value, that is integration value. So find the Fourier transform of fx. So Fourier transform formula is Fourier transform of fx, that is fs equal to integration from minus infinity to infinity fx e raised to I sx dx. This is your first formula. This is your first formula. Then in this integration we have to put fx value. So here fx value are distributed in two functions, that is first value of fx is 1 minus x square when x is in between minus 1 to 1 and otherwise 0 when 1 to infinity, x is in between 1 to infinity. So we have to split this integration because fx is given in two times or distributed in two functions. So we have to split this integration into two integrations by taking the addition of these two integrations. So first integration is from minus 1 to 1. You can take this extra integration, that is this part is given and this part is given, that is function is given. In minus 1 to 1 function is 1 minus x square, and 1 to infinity fx value is 0, and for that minus infinity to minus 1 because the lower limit of Fourier transform formula is minus infinity to. So we have to split this integration three times or into the three types of limits, as minus lower limit is minus infinity. So this minus infinity is not given in this given example, we have to take because the lower limit is given itself in the formula. So we have to take the integration limits or integration, three types of integrations with the limits are minus infinity to minus 1, then minus 1 to 1 and 1 to infinity. In minus infinity to minus 1 the function is not given, so you can take as a fx is 0. Then in minus 1 to 1 function is given 1 minus x square. In 1 to infinity fx is given 0. So we have to split this integration into three integrations, as minus infinity to minus 1 fx value is 0, put here 0 e raised to I sx dx, plus second integration is minus 1 to 1, fx value is 1 minus x square e raised to I sx dx as it is, plus 1 to infinity 1 to infinity fx value is 0 e raised to isx dx. So this integration is split into 3 integrations because 2 conditions are given. Third condition, that is your first condition, minus infinity to minus 1, we have taken extra here, and we have assumed that fx value in between minus infinity to minus 1 is 0, because in a formula the lower limit is minus infinity to so we have to start from the minus infinity and end to the infinity. So these limits we have to cover, lower limit and upper limit. So minus infinity to minus 1, then minus 1 to 1 and 1 to infinity. So here the function is 0, then to first and third integration value is 0. So the remaining is minus 1 to 1, 1 minus x square e raised to isx dx. So here in Fourier transform, generally there is one extra method is introduced to evaluate the integration, that is to use the even odd function concept. So here we have to use the even odd function concept so that we can easily find the or easily evaluate that integration value, or we can easily get that answer of that integration. So here minus 1 to 1, 1 minus x square e raised to isx dx. So this integration we have to find so that we get the Fourier transform of fx answer. So you can take as a homework, or you can check the this integration you can solve by using UV rule directly, because here by Liat sequence, that is LIATE, these are your 5 types of equations: logarithmic, inverse trigonometric, algebraic, trigonometric, exponential. So you have to recognize which type of these two functions are from these functions. So this is your exponential, that is e comes last, and this is your not logarithmic, not inverse trigonometric, not trigonometric, so it is your algebraic function. So this is your algebraic, this is your exponential. A comes first, so this is your first function u, this is your second function v. So if u derivative comes 0 at further steps or at further any steps, then you can use the UV rule. So here I want to introduce the another method, that is even odd concept. So you can check by using UV rule directly to this integration evaluation. So or you can solve this. Here we are using even odd concept. So for even odd concept condition, first we have to use the formula of e raised to I theta. So e raised to I theta formula is cos theta plus I sin theta. So here I theta, the theta angle is which comes with the I. So here Sx is your theta value. So e raised to I theta formula apply to this e raised to I Sx. So we get minus 1 to 1, 1 minus x square as it is. E raised to I theta means e raised to I Sx is cos Sx, that is cos theta plus I sin theta, cos Sx plus I sin Sx. Then split this integration, or take the bracket multiplication as this, don't change this 1 minus x square bracket, keep this 1 minus x square as it is, into cos Sx. This is your first integration, minus 1 to 1, 1 minus x square into cos Sx, plus minus 1 to 1, 1 minus x square into I sin Sx, minus 1 to 1, 1 minus x square into I sin Sx. You can take this I as a constant, which, and you can take outside to this integration sign. So here we use the even odd concept, that is here in first integration there is a product of 1 minus x square and cos term. So here for even odd concept you can remember as a formula that square functions are always even functions, because the even function condition is f of minus x should be equal to fx. So if we replace this x by minus x, then 1 minus x square, that is again 1 x square. So we get, by changing x equal to minus x, we get again original function, that is there is no any change in this 1 minus x square. So in the conclusion we can say that this square function is always even function. So 1 minus x square is your even function. Cos term and sin term, in this again you have to remember this two hints or properties, that is cos term is always even because the both are the periodic functions, and cos term is always even function and sin term is always odd function. So these results we have to use many times in solving the example, or while we use the even odd concept for the evaluation of the integration. So here 1 minus x square, because squaring term is always even function, so this is your even function e. Cos term is always even function e, and we want what is the product of these two terms, is it even function or odd function. So we have to again there is a third property, you can say, there is a result that if there is a product of these pairs, even into odd, odd into even into even, and odd into odd, then the result is, the total resultant function is, if the first function is even and second function is odd, then the product of these two functions again result into odd function. So its product, the product function is odd function. So odd into even is odd function, even into even, the product function is even function, odd into odd function is, the product is even function. So you can remember by taking e equal to plus sign, o equal to minus sign. So plus minus, the product is minus, minus plus, product is minus, plus plus, product is plus, minus minus, product is plus. So this result, and these are the some results we have to use while we use the even odd concept. So here e into e is e, so the total function is your even function, and for even function these limits we can change by using this formula. This is your 12th standard formula. Minus a to a fx dx can be changed into 2 times 0 to a fx dx if fx is even, that is the function inside the integration should be even. Then minus a to a we can change to 2 times 0 to a, and this integration is 0 when the inside integration inside function is your odd function. So here inside function is your even function, so the limits changes to 2 times 0 to 1. Minus a to a changes to 2 times 0 to a, so minus 1 to 1 we can change as 2 times 0 to 1, 1 minus x square cos x. And the second is 1 minus x square is even function, sine function is odd function. So e into o, that is plus into minus is minus, that is odd function. So the total inside function is your odd function. Total inside function, if your total inside function is odd, then that integration answer you can directly write as a 0 value. So this second integration has value 0 because this inside function is your odd function. We get the inside function as odd function. So the remaining integration is 2 times 0 to 1, 1 minus x square cos x. Now you can use the UV rule, because here if you use UV rule directly here, so there will be lengthy calculation. So hence we are using here even odd concept, and this is very powerful method to get the integration value easily in minimum steps. So use this even odd concept. You can easily get this method by solving or by practice of these examples. So here the remaining function is 2 times 0 to 1, 1 minus x square cos x dx. So use here UV rule. So here by lead sequence, this is your algebraic function, this is your trigonometry. So algebraic a comes first and t last. So this is your cos second function v, and this is your u first function 1 minus x square. 1 minus x square, first derivative is minus 2x, second derivative is minus 2, third derivative is 0. So at third stage or third derivative of 1 minus x square is 0, that is u derivative comes 0 at third step. So you can use UV rule. So UV rule, we know this is your u, this is your v. UV rule is 2 as it is. First term is uv1. U is 1 minus x square. V1 means cos sx integration. Use cos b derivative. So cos b integration. Cos b integration is sin b upon derivative of b. So sin sx upon derivative of sx with respect to x. So sx derivative is s minus. So here UV rule is u v1 minus u dash v2 plus u double dash v3. So u v1 means v integration, first integration. Cos sx integration is sin sx upon sx derivative is s. We are using here cos b derivative. So in previous two chapters we use this UV rule many times. So for practicing this UV rule, you can check these videos, previous videos for the first two chapters. So it is not possible to explain that rule in every example. So you can practice these rules in previous, or you can see this UV rule in detail in previous videos. So here u v1, so cos b integration is sin b upon derivative of b. So cos sx integration is sin sx upon derivative of sx with respect to x is s minus u dash. U dash means its derivative, next derivative. 1 minus x square derivative is 1 derivative 0 minus x square derivative is minus 2x into v2. This is your u v1 minus u dash v2 plus u double dash v3. So minus u dash means its next derivative into v2 means v1's next integration. So this is integration is with respect to x. So 1 upon s is constant. So this is multiplicative constant. Write as it is 1 upon s. So I have written direct integration. So 1 upon s as it is, and sin sx integration is we are using here sin b integration. Sin b integration is minus cos b upon derivative of b. So minus cos sin sx integration is minus cos sx upon sx derivative again is s with respect to x. So here that sx derivative s and original 1 upon s. So we collectively we get s square in denominator. Then plus u double dash. U double dash means next derivative of u dash. So minus 2x derivative is minus 2 into, this is your value of v3. V3 means v2's next integration. So here minus 1 upon s square is constant, right as it is, and cos sx integration. Here we have taken already cos sx integration is sin sx upon s, and minus 1 upon s square already there is a constant. So minus 1 upon s square, cos sx integration is sin sx upon x. So in total we get minus sin sx upon s square into s, that is s cube. So here minus 1 upon s square keep as it is, and cos sx integration is minus sin sx upon s. That s and original there is a s square, so we get s cube. So the next term is u triple dash into v4, but we are not writing the next steps or next terms, because the next terms all will be 0, because u triple dash, the next term is u triple dash into v4. U triple dash means u double dash next derivative, and u double dash is your constant term, and minus 2 next derivative is 0. So all the rest of the further terms we will get 0 values. So here we can stop the UV rule and write the limits from 0 to 1. So these limits are for x, because this integration is with respect to x. So first simplify or merge this minus sign. So 1 minus x square as it is sin sx upon s. 1, 2, 3. 3 minus sign means minus 2x cos x upon s square. 1, 2, that is plus 2 sin x upon s cube. Now you can put the limits. So x equal to 1. So 1 minus 1, 0. First term is 0. Minus 2, x value is 1. So minus 2 cos s upon s square. Minus 2 cos s upon s square. 2 sin s upon s cube. 2 sin s upon s cube. For lower limit x equal to 0, you can check easily or fastly to this term. X equal to 0, sin 0 is 0, this term is 0. Here x equal to 0, so 0 into cos 0 is value 1. So 0 into 1, that is 0 term, and sin 0 is again 0. So we get only these two terms. So simplify or multiply this 2 to this bracket, minus 4 cos s upon s square plus 4 sin s upon s square. So this is your Fourier transform of given function fx. Now the next part is hence part. So for hence part, we have discussed in previous lecture that for finding the hence part value, we have to use the inverse formula. So as in first half part, we find the Fourier transform. So for hence part, we have to use the inverse Fourier transform formula to get the hence part. So inverse Fourier transform formula is fx equal to 1 upon 2 pi integration from minus infinity to infinity fs e raised to minus isx ds. This is your formula, and this is your value of fs, that is Fourier transform answer, and this value we want to put here in the inverse Fourier transform. So put this fs value here. So 1 upon 2 pi as it is, minus infinity to infinity, fs value is this bracket into e raised to minus isx dx. So here in first half part, we use the Fourier transform formula. Then to evaluate the integration, we use the even odd concept. Before using the even odd concept, we first apply the e raised to I theta formula in terms of cos theta plus I sin theta, and then separate out these two terms and check the product is even or odd function, and then use the UV rule. We get the Fourier transform answer. Put this fs value, that is Fourier transform answer, in this inverse Fourier transform formula. So put here e raised to minus isx ds. So here now to have the hence part value, we have to compare this given required hence part with this given function or given formula. So in hence part, there is a one term with subtraction in numerator and cos term, and in denominator there is a x cube. So here the hence part is asked in x variable, and here we have all the equation in s variable. So as it is the dummy variable concept, so you can imagine instead of s, you can imagine there x. So here in denominator there is a x cube term. So here we want s cube term should be in denominator. So for s cube term into denominator, we have to take the cross multiplication. So take the cross multiplication, take this 4 outside, so minus 4 upon 2 pi, or take minus 4 outside, take minus 4 common, so minus 4 upon 2 pi, and this term will be minus 4 we have taken outside. So the first term is, or I have written directly, you can check this. So here 1 upon 2 pi, I will let me clear the cross multiplication. So 1 upon 2 pi integration as it is, take this 4 outside, and sin s upon s cube minus cos s upon s square, then 2 upon pi, take the cross multiplication, s square sin s minus s cube cos s upon s raised to 5, then take s square common, so 2 s square upon pi. This you can do in rough, this calculation. So take s square common. So sin s minus s cos s. We are taking s square. So here only s remaining, cos s upon s raised to 5. This s square and from s raised to 5 s square get cancelled. So 2 by pi sin s minus s cos s upon s cube. Then by cross multiplication we get this, and in hence part cos term is at the first position and sin term at the second position. So here we get sin term at the first position, but we want sin term at the second position. So take minus sin common. So minus 2 by pi s cos s minus sin s upon s cube. So this is your term. Minus 4 by 2 means minus 2 by pi integration from minus infinity to infinity s cos s minus sin s upon s cube. This is your cross multiplication. Then now we get s cube in denominator, that is x cube in denominator. So this get matched. Now we want cos term extra in the hence part, but in your formula we have, instead of cos term we have exponential function. So how to convert this exponential function into cos term? So we have to use e raised to minus I theta formula, that is cos theta minus I sin theta. So here theta values is sx value. So e raised to minus I sx is cos sx minus I sin sx. So hence we are converted exponential function into cos term. So we get cos term but sin term extra. So let us see what we have to do with this sin term. But we want cos term. So hence we are using e raised to minus I theta formula to get the cos term in the hence part. So here we get this cos sx minus I sin sx. Then in hence part, if we see, we get cos sx and here we want cos x by 2. So what we have to do to get the cos x by 2 here? So here we have to put, this is important to get the hence part exactly. Here we have to put s equal to x and x equal to half, because don't interchange these values, means s equal to half and x equal to x as it is, but we can't get this term. Here this is your term in s variable and this is your term in x. So we have to, from this first term you can easily check that we have to first put s equal to x conformly. Without putting this s equal to x we can't get this first term, x cos x is x cos x minus sin x upon x cube. To want this term we have to replace this s by x. So replace minus 2 by pi integration from minus infinity to infinity x cos x minus sin x upon x cube cos x. So here we get cos x square minus I sin x square dx. So here if we put only s equal to x, so we get cos x into x. But now in the second we want the cos term with the angle x by 2, and this is conformly we have to put s equal to x. So we get x into x. So what we have to put this originally x, so we have to put this original x equal to half, so that we get cos x into half, that is cos x by 2 term, which we want in this hence part. So what we have done here, in hence part we are using inverse Fourier transform formula. Put the fs value, which is the Fourier transform answer, and by comparing the given hence part value, here there is only one term and in denominator there is x cube, and so that we want s cube in denominator here. So we take the cross multiplication of this bracket, we get the x cube in denominator, that is from hence part x cube in denominator. We get this first term. So for second term there is a cost term extra we want in hence part, but in formula we get exponential function. So here we use the exponential formula e raised to minus I theta, so that this exponential function converted into cosine term. But confirmly we get the cost term by using this formula. So we use here e raised to minus I theta formula to get the cost term. Next we get cos sx, that is sx angle we get here, but in hence part we want cos x by 2. So how to get cos x by 2? So for first term it is confirmed that this is in x variable and we get in s variable. So it is confirmed that we have to put s equal to x here. So we get this required term. This is your hence part term. But in remaining term, if we put s equal to x, so we get cos x into x. But the cos angle in hence part, required hence part, is x by 2. So what we have to change? This s we have to put x. So this is fixed. So what we have to put? The original x as half. So we get cos x into half, that is cos x by 2. So this is your substitution to get the hence part exactly. So here put don't remember this substitution or these values by practicing the examples and by comparing the hence part with your formula or with your formula equation, you can get what is we have to put the substitution, what is the substitution, you can easily get that question. So here don't remember this substitution, just just one by one stepwise we have to compare the our formula equation and hence part equation or hence part term. So here we want in denominator s cube, so we get the cross multiplication. We want cos term, so we use the e raised to minus I theta formula. We want cos x by 2, and here x in this equation is in x variable, so we put s equal to x and original x equal to half. So we get cos x by 2 minus I sin x by 2 dx. So now again by comparing with the hence part, in hence part the sine term is absent. So by anyhow or by using the formulae, trigonometric formulae or any even odd concept you can use here, by using the formulae we have to vanish this sine term, because in hence part only cos term is present here. So to get only cos term, that is we have to vanish this sine term. So for vanishing this sine term, the further steps are separate out these two brackets, as this first bracket write as it is into cos term cos x by 2 dx plus this minus minus plus 2 by pi integration from minus infinity to infinity. So here we multiply these two brackets, as this first bracket keep as it is into cos term minus minus plus 2 by pi integration from minus infinity to infinity. I take outside this first bracket as it is into sin x by 2 dx. Now this first term is your hence part. But by using the formula we get the sine term also or sine integration also. So in conclusion, the conclusion is this second integration will get the 0 value, so that we get the required hence part. So this second integration should be vanished. So for that, for vanishing this second integration, we are using the even odd concept. So here, because again in hence part the limits are from 0 to infinity, and by using the formula the limits are, we get final limits are minus infinity to infinity. So this limits should be again changed. So these limits we can change by using the even odd concept. So for having these limits from 0 to infinity, this term should become as a even function in total, and this should become as a odd function, so that the internal function is odd, then this integration has the value 0 by this formula. 0 value, if fx is the internal function is odd, then whole integration value is 0. So here this integration should be 0 when, if we check this function should come as odd function. So this we have to check in rough, or you can write as it is further. So for that even odd concept, consider this fx value, this bracket into cos x by 2, this bracket into sin x by 2. Let us check this second integration first. So this bracket into sin x by 2, this bracket into sin x by 2. So this is your fx. So check f of minus x equal to, that is replace x by minus x. Minus x cos of minus x minus sin of minus x into sin minus x by 2 upon minus x cube. So simplify this. Minus x cos of minus theta is cos theta. So cos minus x is cos x. Sin of minus theta is minus sin theta. So sin of minus x is minus sin x. That minus sin, this minus sin will be plus. We are using here formulae, just formulae, trigonometric formulae. Sin of minus theta is minus sin theta. So this minus sin and this minus sin get plus. So plus sin x, sin of minus theta is minus sin theta. So minus sin of minus x by 2 is minus sin x by 2 upon minus x cube is again minus x cube. So minus x cos x is cos x plus sin x upon this minus sin, you can cancel this in this at this step. So x cube and sin x by 2 as it is. So this is your f of minus x value. Then check this f of minus x is your fx original function. This original function is we get the original function or not. So this is your f of minus x and this is your fx. So these are the different equations, these two. Hence this is your not even function. So check the condition for odd. For odd condition we have to check f of minus x should be equal to minus fx. So f of minus x we have calculated, just calculate the minus fx. Minus fx means throughout to the given function fx we have to multiply by minus. So minus fx values is this, minus into bracket the whole term, then multiply this minus sign to this. So minus x cos x, this minus minus plus sin x upon x cube into sin x by 2. So multiply this minus sign to this bracket, we get this function. So this equation and this equation are same. So we get f of minus x, this value is here f of minus x. So f of minus x equal to minus fx value, that is f function is odd. Which function is odd? Your second integration function is odd, sin function is odd. So we get this function is odd, hence this integration value is 0. So we get only minus 2 pi u minus to infinity, this cos term only, cos term function. This first integration I have written as it is. Then check this first cos function is cos term, this integration is even or odd. It should be even. So let us check in rough. So here this is your fx value. Instead of you can check this orally. This is your bracket term and into cos. So just replace, don't write the calculation. Orally you can check that, or orally you can check there is no any marks for the calculation. So you can check orally. So one calculation you have written here. So you can orally check for this cos term. So cos into bracket. So instead of sin you can imagine here, instead of sin you can imagine cos. Cos term, cos term, cos term, cos term, etc. So this function is come even function. Even function means f of minus x equal to original function fx. This is your condition for even function. So we get this function as even. Orally we have checked. So write cos x by 2, then cos minus x by 2, and for that cos of minus theta is cos theta. So cos of minus x by 2 is cos x by 2. So by simplifying, I can show you this function is even or odd. Fx equal to x cos x minus sin x upon x cube into cos x by 2. So calculate f of minus x cos of minus x minus sin of minus x upon minus x cube cos of minus x by 2. Use sin of minus theta formula is minus sin theta, cos of minus theta is cos theta. So we get minus x cos x. Sin of minus theta is minus sin theta, that minus sin, this minus sin will be plus. So plus sin x upon minus x cube is minus x cube. Cos of minus theta is cos theta, that is cos x by 2. So this is your f of minus x. So to have this fx function as even, this f of minus x should be equal to fx. So check this. What is the difference? From numerator take minus common. So minus sin x, minus, take minus sign common. So we get x cos x minus sin x upon minus x cube into cos x by 2. So this minus get cancelled, and this is your original function fx. So we get f of minus x, this is your f of minus x value is equal to fx value, that is the given function. This function is your even function, that is this first integration function is even function. So change these limits from minus infinity to infinity to 2 times 0 to infinity. So we get 2 times 0 to infinity, this bracket as it is cos x by 2 dx. So as we have put here x equal to 1 by 2. So in left side there is a function fx. So again we have to change the left side also. So fx put x equal to 1 by 2. So we get f of 1 by 2. So here we have to calculate f of 1 by 2. What is the value of f of 1 by 2? So here we have given fx equal to 1 minus x square when mod x is less than or equal to 1, that is x is in between minus 1 to 1, and otherwise 0 when mod x is greater than 1. Mod x greater than 1 means x is in between 1 to infinity. So f of 1 by 2 we have to calculate, that is put x equal to half in fx. In which fx? Because two values are given for one fx. So which value we have to take? So check this x equal to half is this x equal to half lies in which condition? Minus 1 to 1 or 1 to infinity. So this half lies in the first term, first condition, minus 1 to 1. On this scale this is minus 1 and 1. So here half value lies. So hence use this first function as fx value, fx equal to 1 minus x square. Not we have to take the 0, because for 0 the condition is 1 to infinity and we have to put x equal to half, and this half is in between minus 1 to 1. So take the corresponding function, that is fx equal to 1 minus x square. So consider this fx equal to 1 minus x square, then put here again x equal to half to find the f of 1 by 2 value. So x equal to half, 1 minus half square, 1 minus 1 by 4, that is 3 by 4. So f of 1 by 2 value is 3 by 4. So write in left side f of 1 by 2 value as 3 by 4. Take this minus 2 by pi on left side, we get minus pi by 2, that is minus 3 pi by 16. 3 pi by 4, again take this 2 on left side, so we get minus 3 pi by, after simplification we get minus 3 pi by 16. Integration from 0 to infinity this cos function, and this is your hence part, and the left side is your answer of hence part. So here in this example we find the Fourier transform, that is we evaluate this integration by using the even out concept. For that we convert this exponential function into cosine term, then use the even out function by separating this cos and sine term. A remaining term is only cos term, then use UV rule, simplifying we get the Fourier transform answer. For hence part we use the inverse Fourier transform answer, inverse Fourier transform formula. In that we put the fs value and by comparing one by one terms from the hence part, we get we take the cross multiplication, then exponential function converted to cosine term, then separate out the cos and sine term, and second sine term function we got odd function, that is the value is 0, and for remaining cos term the internal function we got the even function. So limits are changed 2 times 0 to infinity, and by simplifying with the left side, for left side the substitution is remaining. For having the hence part, that is in hence part there is a cos x by 2 term, so for having cos x by 2 term we replace here, again having this equation in terms of x variable, because the hence part, in hence part this term is in x variable, so we first replace s by x, and then for having cos x by 2 term we replace x equal to half. So using this substitution we get the hence part answer on the left side. Thank you.